color picking, which I think it's more than enough. Okay, this thing have its own plus and minus, but I think that's for this device. Okay, color picking is just fine. I saw also that on the forum people want to use like the bullet picking version. Like you can use bullet to pick object in 3D space. It's another good way to do it. Also, SIO2 provides you SIO2 on project that is basically acting like GLEU on project. So this is done like all on the CPU. It's a little bit slow, but this thing can give you good results to be able to get like point 2D to 3D, and after that like do a test, a ray test or something. I can show that also in another tutorial if like people are requesting it. So okay, I'm going to continue to finalize my scene here. I will go back in the object in the model, and I will simply quickly add the other objects that are supported, like cone. Okay, that's another physics bound object, and this time I will do it like I will do the same thing, okay, but I will do it like quickly. D, D, and D. I'm going to scale a bit. I'm going to scale a bit. Take this one and go text paint. Go search another little sweet color. Nice. Actor, dynamic, rigid body, bounce, and cone. Go back in object mode. Here, actor, dynamic, rigid body, bounce, cone. Actor, dynamic, rigid body, bound, and cone. Actor, dynamic, rigid body, bounce, and cone. And I'm going to select everything and make sure that everything is centered. Okay, so that's it for cone. And I'm going to use the last type. Okay, I'm going to use monkey for this one. And it's worth mentioning that, okay, what I'm going to, first I'm going to duplicate this one here, LD, scale, rotate, scale, rotate, and I'm going to paint this one. Let's go search like something like gray. Okay, for Suzanne here. And select everything and center new. Okay, then select my first Suzanne, and this one, actor, dynamic, rigid body, bounce, and convex all polytope. Okay, this is actually this one is actually the most convenient, but it's actually also like the most slowest one. Okay, basically this type of bounce give you the opportunity to add any type of 3D object from any shape, and basically the points, every unique point and every unique vertices will create your physics object. So yes, it's the most convenient one, but it's also like the slowest one. So I would suggest you to use those basic one as much as you can, and if you really have like no other choice, okay, you use this type. Like an example, like for a player or a non-player character, okay, this type would be good, but it's another thing that you should handle with care, because this thing requires like a lot of calculation from bullet. Actually, when you start profiling, if you are interested in profiling, you'll see that basically bullet is really what takes the most CPU, okay, like when used with the engine. It's even like more slow to render than drawing itself, okay. So the physics is, you really should use the physics like wisely. Basically reading like the Blender documentation, like they say that triangle mesh, okay, like large triangle mesh, like an example for the environment, it's like really what gives the best results, okay. And the larger it is, the less physics object you have, the better performance you will have also, okay. So imagine that you have like a large terrain, what I would suggest is two choice, like one big triangle, static triangle mesh, or you're doing your own collision map. Okay, and for this one, I'm going to show you right now how to implement your own collision map. Okay, but I'm not going to implement, like, create a custom one for the ground. I'm simply going to use static triangle mesh. I'm just going to create a collision map to, like, forbid the camera to go out of, like, the boundaries of our world here. But first of all, I will like export this one. Okay, select everything and go back in scripting. I just want to make sure that everything is set properly and all my monkeys are, oops, that all my monkeys exactly are set with the good type: rigid body, bounds, and convex all polytope. Actor, dynamic, rigid body, bound, and convex. Actor, dynamic, rigid body, bound, and convex. Okay. Then select everything and okay, update. Run. And now we can see that everything in my world is behaving properly here. Okay. Here we go. The performance is pretty good on the simulator, because of course you're using like the CPU, but when you're going to run it like on a real device, you'll see that the thing is a bit different. And I already had people, that complain like, why, like, the way I'm stepping the simulation, okay, inside SIO2, I had to tweak a little, because if I'm using like the default and real value with, like a progressive, simulation pass, more than one simulation pass, it's just going to slow things down too much, like on the device. So what I'm doing is I'm tweaking it a little, like make it work the way, in another way, in order to be able to gain, like some speed. Okay, and the last one, the last part, I'm going to introduce how to create your own like collision map. This one is basically like really simple, but I think it's like good enough as for demonstration purpose. So I'm going to go back in my scene and I'm going to add mesh and I'm going to say cube, and I'm going to scale it like crazy here to be about like the same as the boundaries of my scene. Okay, something like that. And here you can see that this will cause me problem, because basically here I create a new cube and I already have a cube, so cube.005. So when I'm going to export, the exporter will think that this is an instance of my previous cube that I create here, which is not cool. So I'm going to rename that object and call it collision map. Okay. And I'm going to go in front view and I'm going to scale it, because that's like really too much, and put it at the good location. Basically what I want to have is just like walls. I just want to create this geometry to have walls that's I'm going to put like a material to. Okay. So I'm going to select my collision map and edit. I'm going to get rid of the top, and I'm going to get rid of the top, and I'm going to get rid of the bottom. What I want to keep is really just like the walls of it. So basically my camera will stay in, within that area. I will not like fall down